So today I'm going to show you how to use Fusion together with Dynamo, software from Autodesk that is a visual programming interface. I've created a surface in Fusion. The first thing I'm going to do is I'm going to export this out as a SAT file. Dynamo does read in geometry from CAD files, but it doesn't read in Fusion files natively, at least not yet. So I'm going to export this first as a SAT file and save it on my local machine. Entering into Dynamo, you're going to see that it's a visual programming interface, basically. And I can search using basic commands like path, and that'll give me a little command that I can place somewhere out there. And this allows me somewhere on my computer to go search and find a file. It actually doesn't find a file, it just finds a path at first. And then I'm going to go and say import from SAT. This is another little piece of programming code. I'm going to place it here, and I use these little connectors between the two because the import from SAT wants to know, well, where are you going to import it from? Where are you going to import it from? So in that case, it's going to use the path command that I had previously defined to go find out where that comes from. Now I've got a bunch of geometry already in the program. You might not believe me because I didn't scale everything because it's all very small. It's a SAT file without any dimensions associated with it. So the very first thing I'm going to do is I'm going to take the scale command. Now there's several different kinds of scale commands. I just took the scale with the scale factor, a uniform scaling around the origin, and I need to tell it by what amount. Now the first thing you'll notice is that it gives you an error because my amount is a scale of 0. That doesn't really make any sense, but if I go in there and change that little number code into 1,000 to get my millimeters, I'll get a file that is then the correct size within Fusion, or within Dynamo, I'm sorry. Now, it's handy sometimes to group these things together. So I just put a window around these, and I said I create a group, and I'm going to call that the geometry import group. This is a very common command structure that I use over and over again, and as a matter of fact, you can store it. Now you'll see, after the program takes a little bit to run, that file will now be visible inside the geometry area. Dynamo is split up into two different visual areas. One is for your programming interface, and the other actually shows the geometry being created, manipulated, and used. You can switch between the two of these using the commands at the top right, or you can use right mouse button functionality as well. Now that I've got geometry, I'd like to do something with it, and there's a command called structure by mesh, which basically takes the surfaces that we have and will put a mesh onto those. In this case, a square mesh. And so I'm going to take those surfaces, which you can see were there before from my import, and I'm going to put them into the import of structure by mesh. I created another slider. It's another little programming bit of code that is included within Dynamo to take an integer slider. And this allows me dynamically, using a sliding interface, to define integers. In this case, between, I think I said 2 and 25, something like that. I set my limits and my increments. And by moving this slider, I can divide the surfaces into a number of sections based on the local U and V. That would be the local X and Y coordinates along the face of the surface. So you see this creates a grid that basically follows the contours of the surface. Now if I make more, they will follow it better, obviously, because it basically makes straight lines. And if I make less, you get less of these, and eventually they'll just sort of make a round box. But in any case, I can do that, and I decided to make it uniform, to have the same number top to bottom as left to right, but you don't have to do this, of course. Now, this gives me not only a grid, it also gives me points where all these grids come together. And these are shown in the structure by grid programming box as separate items. And then I can take those lines out that I've created specifically, and I can use another bit of code called pipe. And that pipe will then thicken these lines by a set amount. What set amount? Here again, I'm going to use a number slider. This time it's not going to be an integer slider, it's just a number slider. I'm going to set some limits for that. I think it said 0.5 and up to 25 or something like that. And then using that slider, I can thicken these lines by the amount that I define. And if you give it just a second, you'll see that it will instantly update within the Dynamo interface. So now I've got 3D geometry that was developed from that original surface that I created in Fusion, and it can give me some really nice effects. And by using these sliders, I can dynamically change things such that I can experiment. I can see what I like better. Do I like more or less? And each time I change this, I just have to wait a bit, and then the program will update. It does take a bit. Here again, I'm going to create a group and say, this is, I think I called it a geometry manipulation group or something like this. So, can change the color, make it look nice. So this is quite good, and I could again use this over and over again. This is a quite common set of commands that are used quite a bit. As a matter of fact, you'll see them all over the internet, all over YouTube as well, and there's a lot of other ones. You might look at some of my other videos for some other ideas. Now, once we have this geometry, the big question is, how do we get it back into Fusion? How do we get it into a CAD program, or how do we get it into a system, like a CAM or anything else that we might actually want to do with this? You never know. One of the things one of the things I'm going to do is I'm going to say export. Well, I can export, and there's a command for that, export to SAT, which I could then read back into Fusion, as a matter of fact. And I could put that directly in, but if you look at these pipes, you'll notice it's in an array. It separates each and every one of these bodies, also not only by the body number, but also by which surface it happens to be located on. So I have a list, an array of 1 by 2. And that's not so easy, because if I just export that as well, I'll just get the first list and not the second. So I'm going to use another command, and this is something you do quite frequently when you need to do these, simplify these lists. I'm going to use another command called flatten. And flatten will just take all the lists that are in there, all the surfaces, and it will combine them into one giant list. So each body will now be no longer held to its corresponding surface. They'll just each be bodies in their own right, and they'll all be on one list. And then taking it out of the flatten, that one list, I'm going to put that back into my export to SAT. Here again, I'm going to have to define a path where I should export this to. So I'll use the same command from before of file path, and I'll put that in, and I'll decide now where I would like to store that on my local machine. I created a file called video output. Now, the last thing I have to do is define the units, because SAT is a unitless CAD file. And whether or not you believe it or not, that thing is already there. It's already been created. In the moment I did that export file, it wrote that file out. I'm going to do the housekeeping work that I've done before and create another group and call this the export group. I use this over and over and over again. Just wanted to keep things neat for you. And then I can go back into Fusion with no problems after I've found the perfect solution that I'd like. I can keep going and manipulate my sliders, change things around, find out just how I'd like this thing to look. And each time I do, the program will run all the way through and will rewrite out that SAT file. So now I can go back into Fusion, I can create a new file, and I can create a new construction, a new construction from a file. Go grab that SAT output file that Dynamo is writing out the whole time. And there's quite a lot of bodies here, so it takes a few seconds. But once you do, you're going to notice that all these bodies in this wire mesh comes in just as we had it into Dynamo. Now, this is not a dynamic update because we're reading a static SAT file, but if you make some changes back into Fusion, you can go back in and reread that SAT file in, and you'll get the file that you wanted right out of Fusion. Hope you enjoyed it, and hope you can use it, and look at some other videos that I've created to show you some other ideas what you can do with Dynamo. It's quite powerful.